calculation. Hope you understand. So now let's come back to the session here with the question number 9. I think the last problem, I think all of you understand this problem, right? It's a very simple one. So let me start this session with question number 9. So what is the problem given here? Just read out. Find the current through a 5 Henry inductor if the voltage across it is V of t is equal to 30t square for t greater than 0, 0 for t less than 0. Okay. Now what is he asking actually here? Look at that problem, all of you. What is he asking? Find the current through, and he gave a voltage, and also is asking, and also find the energy stored within okay 0 and 5 seconds. Understand? Very simple problem. What is given? Voltage given, and it is actually related to what inductor problem. What is the formula that you are using? IL of t, current through I of t. Okay, I of t naught plus t naught, let us assume 0. Okay, 1 by L. What is that inductance value? 5 Henry inductor. It is 5 Henry inductor. Okay, so integration 0 to t. What is that? V of t dt. He did not mention anything about the initial current directly or indirectly. Therefore, it can be taken as what? 0. So 1 by L. What is 1 by L? 1 by 5. 0 to t. 30t square dt. 30t square dt. Okay. So 1 by 5. What do you get here? Into 30. T square is nothing but t cube by 3. Yes or no, all of you? Okay. So 5, 6 ja, 3, 2 ja. Finally, you got 2t cube. Okay, amperes. Yes or no? 2t cube amperes, because that is given Henry. This is given in volts. This is completely volts given. Therefore, it is in amperes. This is what the current. Now, what is expected to find actually here? To find even energy. Energy within some boundaries he has given. What is the formula for energy in case of an inductor? You know that very well, right? What is the formula for energy? Within boundaries he is asking. T naught is 0. T is 5. Okay, so what is the energy formula that you have learnt already? Energy is, okay, half, of course, W of 0 plus half L I of t square minus I of 0 square. Yes or no? Okay. What is that I of 0 actually here? Did he mention anything about initial current? No. Therefore, let us take it as 0. Okay. Now, do you have any information regarding this? No. So, what do you take? Half L. What is this I of t? Is I of 5 whole square. This is already, you know, L value is nothing but how much here? 5 Henry. Yes or no? Now, let us calculate this I5. I5 is nothing but what? 2 into, that is 5 cube. How much it is going to be? Okay. 5 5 is 25 into 5, 125 into 2, 250. Okay. So now you can just go for that. 1 by 2 into 5 into 250 whole square. So finally you can simplify. You will get an answer that is 156.25 kilojoule. Understand all of you? Okay. Please note down that. Please note down, all of you. 156.25 kilojoule. So this is how you can do the problems, very simple problems. We have so many, we'll discuss few more on this. Question number 9 is over. Then let's switch over to question number 10. Question number 10. What is that question number 10? In the following circuit with DC conditions, find the energy stored in the inductor and capacitor. Okay, 2 Henry, 5 ohm, 4 ohm, 1 farad. This is VC. This is some current IL given. This is 1 ohm and 12 volts. So what is asking actually, in the following circuit with DC conditions, the energy stored, find the energy stored in the inductor and capacitor. Very simple problem, right? So already you have the formulas, right? WL, what is WL, Nana? Half L IL square, WC half C VC square. Now let's try to find that IL and VC. You know that this is acting like open circuit, this is acting like short circuit under DC conditions. Under DC conditions, you have open, short, IL plus minus VC. Okay, this is 1 ohm, 5 ohm, 4 ohm, 12 volts. Now you tell me what is IL. Since it is open directly, 12 by 1 plus 5, 6, right? 2 amperes. Now what is VC? The voltage is nothing but the voltage across 5 ohm only. Yes or no? So the voltage across 5 ohm is how much actually? 2 ampere. 2 into 5, 10 volts. Now from this you can observe that half CVC square, right? What is C? 1 farad. What is VC? 10 square. So 100 by 2, 50 joule. Here half L how much? 2 Henry. IL how much? 2 ampere. 2 square. 2 gets cancelled. Finally 4 joule. So WL 4 joule. WC is 50 joule. Okay. These are very simple problems. That's the 10th problem. Okay. That is 10th problem. Done, all of you? Now 11th problem. Question number 11. Classroom workbook, question number 11. The current through a 5 millihenry inductor is shown in following figure. Determine the voltage across the inductor at t equal to 1 millisecond, t equal to 3 millisecond, t equal to 5 millisecond. There are three questions asked actually here. Now, this is what the waveform given. Two, 4, 4, 6. That's it. Yes or no? Okay. 2, 4, 6. 0, 2, 4, 6. That's it. So this is what actually given current. Current is in amperes and time is in millisecond. Okay. So what is expected to find here? Is asking voltage across the inductor. So what is the relation between voltage across the inductor and current through inductor? You know that voltage across the inductor is L into dIL of t by dt. Here I is given. Nothing but L into slope only. So don't go for straight line equations calculation. Simply go for slope of I of t. Now you can take what is the slope of it? Actually, this is given how much? 10, right? 10. So what is the slope of it here? Slope is nothing but 10 by 2, 5 amperes per millisecond. Here, slope is nothing but 0 amperes per millisecond. Here, slope is nothing but how much it is? This is 4 comma 10, 6 comma 0. What is the slope? 0 minus 10 by 6 minus 4. How much it is? Minus 5, okay, amperes per millisecond. Understand all of you, okay? So you got now the slope. Then what is the value of voltage? L into slope, right? What is L actually here given in the problem? 5 millihenry. This is 5 millihenry is the inductance value. Substitute here. What is now VL of t? Okay. Here 5 into 5, 25 millihenry per millisecond. Both gets cancelled. This is 25 volts. So therefore, 25 volts for t between 0 to 2. 0 volts for t between 2 to 4. Minus 25 volts for t between 4 to 6. That's it. It's very simple. So now here, if we can go with t millisecond, 2 and 4, and this is 6. Yes or no? Okay. So what do you get here? Voltage. Voltage V of t, voltage across the inductor. Even if you draw that waveform, how it looks like, this is 25, then 0, then minus 25. 25, 0, minus 25. This is 25, this is minus 25. That's it. This is 2, 4, and 6. You understand all of you, okay? It's a very simple problem. You can easily do. Note down that quickly. I just meanwhile take another problem here. Question number 12. Okay, question number 12. Question number 12. If the voltage across a 5 Henry inductor is shown in the following figure, calculate the current through inductor. Assume that I of 0 is equal to minus 1 ampere. I think all of you are reading that question. Hope all of you read that question. Try to understand the data given. If the voltage across 5 Henry inductor is shown in the following figure, calculate the current through the inductor. He has given the voltage, but voltage function has not been given. Instead, he has given us the waveform. If you have waveform, you know how to obtain the mathematical form of it. Yes or no? So let's try to find that. 5 Henry inductor, right? And I of 0, it's very important to be observed. I was telling you that sometimes he will give you directly or indirectly the initial values also. This is 0, 1, 2, 3, 4, 5. This is 10. This is what actually given voltage, right? Voltage across the inductor is given and asking you to find current through the inductor. Okay, it's a very important problem. You can observe how you can solve it. Okay, you can just see here how I am solving. Don't write anything until I tell you. This is over, right, all of you? So let me solve that problem. Hope you have drawn that, all of you. Draw the diagram once again. Okay. Now look at this, all of you. What is actually given and what is asking? This is what the voltage waveform and is expecting current, right? So current is nothing but what? In the case of inductor, I of 0, integration 1 by L, integration 0 to t, V of t dt. Yes or no? So first you have to find V of t, then go for integration. Yes or no, all of you? But already you know that I of 0 plus 1 by L, area under V of t over the boundaries 0 to t. Can I write like this, all of you? Yes or no? Okay, I can write. Yes or no? Now, I would like to find the current through the inductor. Actually, what is the question he has asked? Find the current through the inductor. He did not mention the current at which point he is actually expecting. When he is not mentioning the current at a particular point, that means he is asking the total current. That means he is expecting the current at an instant. What is this? T equal to 5 seconds. Understand, all of you? Okay. See, he did not mention where we need to find the current actually. He did not mention whether current is required at 3 seconds, 2 seconds, 4 seconds, 1 second. He did not mention at all. That means he's just asking the current, total current. Total current or current at an instant 5, that is end current, actually end time, sorry. The time is what actually, this is what the end time where the waveform has been terminated completely. At this particular point, the current, if you calculate, it is nothing but the total current that passed through the inductor you can easily get. Understand, all of you? Okay. So let us look at that. I of 5 we need to find. That's fine, that I of 5 I can easily find, no doubt. But tomorrow he may be asking you I of 1, asking you I of 2, or some other time. Therefore, that's why I'm just trying to do it in a systematic manner. Okay, I can get meanwhile this answer also, no doubt, at the end of my solution. But I'm trying to give you the solution, how we can find, even if it is asked at any point of time, the current through the inductor. I just want to really explain that. Look at this, all of you. First, I would like to find I of 1. Can I write something like this? The area over 0 to 1, 1 by L. Yes or no, all of you? 1 by L, area under V of t. This is a V of t. What does this tell me? I of 0 is how much? Minus 1. What is the area? Tell me. This is what the area. Yes or no? This is what the area. Area 1. Area 1 is nothing but 10 into 1, 10 divided by 5. Yes or no? So therefore, 1 by 2 into 10, nothing but how much it is? I'm sorry, this is 1 by 5, right? Okay, 1 by 5. So 5 2 ja, 2 minus 1, this is 1. Understand? Okay. So you got now, this time is in seconds actually given. Yes or no? Let me cross check once. Yeah, time is given in seconds and the voltage is given in volts. Then current I will be now in amperes. So where do you get that particular point? Even if I want to draw that waveform also, I can draw it easily. Okay, but I will come to that point later. Now next, I of 2. What is I of 2? I of 2 can be written as something like this. Either I can write I of 0 plus 1 by L A between 0 to 2, or I of 1, I of 0 or I of 1 can also be determined. Okay, I can also use I of 1 plus 1 by L area, but this time I must take 1 to 2 instead of 0 to 2. If I take 0, here it is 0. If I take 1, here it is 1. Hope you understand the point. Simple. Okay, if I take 0, this is 0 to t. If it is 1, 1 to t. If it is 2, 2 to t. Like that I can take. Understand all of it? Therefore, now anything you substitute here doesn't matter. You'll get the same answer. Now I get here minus 1 plus 1 by 5 into, what is the area actually here? A2. A2 is how much? 0. A1 is how much? 10. Yes or no? There is no signal here. Therefore, you got now again, okay, the same 10, that is 1 ampere. Understand all of you? Okay. Area 1 plus area 2 actually, but area 2 is not there. Yes or no, all of you? Okay. So this is what actually you got. Let me write it clearly, otherwise plus 0, it's nothing but again 1 ampere. Now I of 3 I would like to, that means total current that passed through the inductor at t equal to 3 seconds here. Okay. Now what is that value? Again I can write I of 0 plus 1 by L. Okay. That is how much it is? 3, right? Okay. 2 to 3 or 0 to 3? 0 to 3, right? Okay. Or else I can write that I of 1, 1 to 3, I of 2, 2 to 3. Anything is okay. Understand? Okay. I of 1, 1 by L, A, 1 to 3, or else I of 1, I of 2 plus 1 by L, area from 2 to 3. Anything is okay, because this is the general formula you have. If you substitute T naught here, then T naught to T. T naught 0, then 0 to T. T naught 1, then 1 to T. Like that you have. Same thing I'm writing. So just if you write here, what do you get? I of 1 minus 1 plus, what is this actually here? A3, right? A3. Nothing but A1 plus A2 plus A3. What is A1? You know very well. How much it is? 2. A2 you know very well. How much it is? 0. A3 you know very well. Again you get what? 2. Yes or no? Okay. Yes or no, all of you? You get finally that area, okay, divided by that, you get actually something like this. I'm sorry. Let me explain once again here clearly. Let me write it clearly. I've just written directly, but I would like to. It's not simply A1, A1 by L, A2 by L, A3 by L. So finally you got minus 1 plus 2 plus 0 plus 2 again. How much you got? 2 plus 2? 4. 4 minus 1, it is 3. So 3 amperes you got. Okay. I of 4, how much you got here now? I of 0 plus 1 by L, area from, can I say 3 to 4? Yes or no? Yes or no here? Sorry, I of 3 here. Okay. I of 3 I can directly write. If I write 0, I get 0 to 4. If I write 3, I get 3 to 4, because already I have I of 3. How much I have? I of 3 here? 3. So 3 plus, what is this? It's nothing but area 4, 0. This is area 4. This is 0. Finally, answer is what? 3 ampere. I of 5, I can take I of 4 plus 1 by L area under 4 to 5. So what do you get? I of 4 is nothing but 3 plus, what is this value? 1 by L A5. What is it? A5. A5 is 10. A3 is 10. 10 by 5 to 5 ampere. I think all of you understand now. The answer to the question actually is, you can directly solve this particular problem like this. Okay, I5 you are supposed to calculate actually, but I determined intentionally. In this question, he asked only I5. But I did, for more clarity, for make you understand, better way, I have calculated everything. I of 1, I of 2, I of 3, I of 4, I of 5. But the question is only I of 5. What is the total current passed? Or what is the current passed at time t equal to t equal to 5? That's it. Okay. So therefore now you got the answer. This is what your answer actually. But I just, out of, to make you understand a better way, I just calculated the remaining parts also. Look at this. We can even draw the corresponding current waveform. On the same waveform, I would like to draw. Look at this, all of you. I of 1, how much? 1 ampere. Let me take current also on the same axis with the same scale. Now 1 ampere. This is 5. This is 5. Now this is 1, 2, 3, 4. Now this is 4, 3, 2, 1. Okay. So I of 1, what I of 0 is minus 1, right? I of 0 is what? Minus 1. Here it is minus 1. Minus 1, 1, 2, 3, 4, 5. This is 6, 7, 8, 9. Understand? So this is what actually I of 0. You got minus 1 ampere. But what is I of 1? You got 1 ampere. 1 ampere means this one. Yes or no, all of you? But how do you join these 2 points? You know that voltage is a step function, but current is the integration of voltage. When you integrate step, you get ramp. Yes or no, all of you? When you integrate step, you get ramp, or when you differentiate ramp, you get step. You already know that. Yes or no, all of you? Okay. So when I integrate the step function, I get the ramp. Therefore, ramp is nothing but a straight line. Let me draw these 2 points with a straight line. This is a straight line. I of 2, still it is 1 because there is no signal, right? So understand? Okay. Now next, what about the I of 3? I of 3 is 3. Now this is 1, 2, 3. Understand, all of you? Okay. You got this, all of you? Now I'm just joining the straight lines I'm getting. Why straight line? Because you are integrating the step. You are integrating the voltage. The result is a step. The ramp. Okay. When you integrate the step, you get the ramp. Okay. Next, I of 4. What is I of 4? Same. That is 3. Now I of 5. What is that? I of 5 is nothing but 5 ampere. This is what the 5 ampere. Somewhere around. Like this. Therefore I get. So this is what. Okay. This is the voltage waveform. Its corresponding current waveform. I of t. Okay. At time t equal to 5 seconds, this is what the total current that passed through the inductor. Understand, all of you? Okay. So please note down. It's very, very interesting problem. This type of calculations are very important because in the exam, the questions are coming in the similar manner. Okay, I have elaborated the problem, but the question is very simple. He is asking only I of phi. So I of phi means what? It is I of 0 plus 1 by L A 0 to 5, or else I of 4 plus 1 by L A 4 to 5. Anything is okay. Okay, so we stop the session here, and in the next session I'm going to discuss some more problems, very interesting problems which were asked in GATE on inductors and capacitors. Okay, so I just stop here. We'll discuss in the next session.